Hey everybody, Michael Snyder here, Pacific Northwest Weather Watch, and today I just thought I'd go over the update here on El Nino, July 13th. These are put out monthly here, and I just thought we'd go over some of the highlights and go over some of what we can expect here across the Pacific Northwest and down through the state of California here as we go through El Nino this fall and winter. So this was issued today, and still dealing with that 90% chance that El Nino will continue through the northern hemisphere here, hence the El Nino advisory. And we are right on the cusp there of moving into moderate El Nino conditions here. The last reported temperature there was about 1 degree Celsius, which is on the lower end, just on the cusp of the moderate El Nino. The Southern Oscillation Index is now fluctuating a bit here. We're getting some variability going on here, but I'll show you what that is here in a moment. Stay with me. And an event that becomes historically strong, seasonal average Nino 3.4, rivaling the winters of 97, 98 or 2015, 16, has approximately a 1 in 5 chance. It could still happen, but it's backed off a little bit here on some of the calling for a very strong El Nino, but we still have a decent chance of headed towards a strong El Nino coming up here. Now, taking a look here, you can see, and this shouldn't be a big surprise, we have a good chance of heading towards that moderate El Nino this fall and winter and going on into strong, a little bit better than a coin flip at this point. Now, this is looking at the Southern Oscillation Index. I did mention that coming up, but you can see how long we've been in this La Nina pattern here. The last three fall-winter seasons have been La Nina. Now, as I scroll through these months, you'll notice as we get to May 2023, look at that, negative 1.0, kind of a reversal there, kind of the sign of that impending El Nino coming up. But they throw a little wrench in the system here as it's went back to positive here just briefly. That shouldn't last long, but it is a little bit of an interesting pause, although not totally uncommon during a developing El Nino. Now, this is looking at French Polynesia. There's Tahiti there, and there's Darwin. So when you have a higher pressure here, you tend to have more westerlies, and that westerlies are a sign of stronger trade winds, which pull away this warmer water from the coast of South America, and you get upwelling and you get the cool tongue across the equatorial Pacific for La Nina conditions. When you get the reverse and the pressure is higher across some of the western Pacific, you reverse that and you allow that water to bunch up here and start to warm up and bring El Nino conditions across the equatorial Pacific. So that's what the SOI is, a Southern Oscillation Index, a difference in pressure between Tahiti and Darwin, Australia. This is looking at June 1997, one of our most powerful El Ninos ever recorded here. And you can clearly see that warm tongue across the equatorial Pacific built up on the coast of South America. But also notice the temperatures around the rest of the globe during this time frame. Kind of a mixed bag here. But now watch what happens as we go to June 2023. Look at the dramatic difference in the rest of the planet here, how much the oceans have warmed up here. You can see the tongue for El Nino there, but how is this going to play into what we get this fall and winter? We're kind of in uncharted territories here, as we have definitely warmed up the oceans quite a bit here since 1997. This is current sea surface temperature anomalies, or at least showing the last 30 days or so. We started about June 13th there, and you can see that warm tongue El Nino conditions still ongoing. Cooler water here across California, just kind of a sign that El Nino is not being felt around the globe here as far as atmospheric circulations just quite yet. We'll eventually get there most likely, but you can really see that warm water off the coast of South America, and that's where that El Nino name came from. They noticed that during the Christmas time, the Christmas season, that warm water would come there every few years, so they kind of named it El Nino. This is looking at every El Nino since 1950. You can clearly see we are kind of right on the same timeline as many other El Ninos, passing into our spring and summer months as we increase here and going on into fall coming up. So you can kind of see the evolution of this, then drop back down as we go past the new year, and who knows what's to come after that. We'll deal with that as we go on into the fall and winter months. This is looking at our forecast confidence here, 95% here, confidence that we're going to be above the moderate El Nino conditions for the most part. I mean, it said 82%, but really our forecasts are saying that we're almost certainly going to be in El Nino conditions. And you can see 68% here, which is right about, moving into strong El Nino territory coming up. This is what's going on across the atmosphere. You can see Australia down here, South America, there's Mexico. This would be a La Nina setup. You can see the cool tongue moving out across the equatorial Pacific. Deeper convection with the warmer water here across the western Pacific, and that tends to bring a stronger jet stream off the coast of Asia across the western Pacific, which in turn brings a more variable jet stream to places like North America, Pacific Northwest. Now look when we reverse things up here, the warm tongue across the equatorial Pacific, the Walker circulation direction has changed. It's now out over the central Pacific Ocean a bit more. So you get this energy transfer at a little different location here, bringing a more persistent jet stream into the southwest USA that can even affect up into the Pacific Northwest as well, and makes a lot of North America warmer because of this setup. This is kind of the general rule here. A lot of North America, again, warmer. You can see the enhanced jet stream into the southwest, some wetter conditions, some colder conditions, and even drier conditions across portions of the east. Kind of typical here. But again, I've said this before, all El Ninos are not the same. This is kind of a probabilistic forecast. Things can vary greatly here, especially during the season. Now, this is looking at 2023. You can see during May, we are officially 0.5. I think June's going to come in at 0.8 here. Still, we are behind that 2015, 2016 Godzilla El Nino. I'm looking at some of these temperature anomalies across the equatorial Pacific, just kind of ridiculous there. So we are behind that, and we're actually still behind the 97, 98 El Nino as well. We're at 0.5 and 0.8 here. So I don't know if we're going to get there. We don't know how this is going to work out. You know, we're dealing with different factors as well, as much of the oceans across the planet are quite warmer compared to that 97, 98 as you saw. Okay, so I've moved my head to the bottom right here, so I'm not going to block any more of the incoming text, but the El Nino Southern Oscillation is one of the most important climate phenomena on the planet due to its ability to change the global atmospheric circulation. Of course, this influences temperature and precipitation across the globe, and we focus on this because we can often predict its arrival several seasons in advance. It gives us a good heads up of what's potentially coming during the fall, winter, and early spring season. This is something interesting for SeaTac, and this is El Nino December. It's 47 miles per hour average peak gust here, the windiest of all La Nina, neutral, or El Nino months. Now we're taking a look here at temperatures. Look at the mean temperature between El Nino months and La Nina. Big differences there. And if you go to March, 45 versus 48.3, those are big differences. You know, that's a very good chance we're going to be dealing with some warm late winter and early spring conditions if we were still in El Nino conditions by this time next year. You can see January is significantly warmer as well. April also. The only month that wasn't warmer was actually November, and just by a hair. You can see by a tenth of a degree here, but big differences here. And you can see neutral years over here kind of falling between the two. Again, 1979 to 2023. Here we go with precipitation. Actually, look at this. During the 79 to 23 period, you can see that December's and January's were both rainier here during El Nino conditions. Kind of interesting here, even though La Nina Novembers tend to still remain king with over 7 inches on average. Now, taking a look at California, let's see how this affects California. This is, El Nino had big implications here. Sometimes impacts are likely to be greater in late winter than early winter. Southern California has a stronger chance of wet conditions than Northern California. And in case of very strong El Nino, heavy precipitation is more likely across the entire state, although it is not a guarantee. And Northern California precipitation is weakly influenced by El Nino phases, or ENSO, El Nino Southern Oscillation, probably due to normal variability with the mid-latitude cyclones. I'll show you a little clip on that here in a moment. The correlation with ENSO phases is stronger for Southern California. However, makes sense because it's closer to the tropics, right? Now, this is what we call Rossby waves and kind of natural variability here as these polar lobes are swinging by, and you can see these reach down towards Northern California. Of course, it's going to have more effect in Northern California versus Southern California. It's kind of the natural variability as the colder air pinwheels around the Northern Hemisphere. Now, taking a look here, if you look for California here, moderate to strong El Ninos do bring increased moisture, CAPE, and precipitation, kind of in the same longitude here, I should say, as California, located right there. It's somewhat of a notable signal here during El Nino years for the most part, but again, it's not a guarantee. Warmer sea surface temperatures enhance deep convection and increases precipitation anomalies. Walker circulation is close out there. Remember, we went over that here a little bit ago. Now, taking a look here, you can see November, December, January versus February, March, and April. You can see a stronger flow here during moderate and strong El Ninos here that tends to bring those bigger precipitation values for Southern California there as you go on in through the later portions of winter and even into early spring. Now, here's looking at the flip side. We're looking at weak El Ninos now, and you can see again November, December, January on the left, February, March, April on the right, and you can see there is a bit more flow here, but it's nothing really compared to when you're dealing with the strong El Ninos. But as I'll show you coming up here, just because you have a strong El Nino does not guarantee California an above average winter here. And sometimes those storm tracks can be a variable and they can move up towards Pacific Northwest, such as what happened with the 2015-2016 El Nino. And we'll look at that here in a moment. But now taking a look at the scatter plot here, you can see that Southern California during February, March, and April here, look at the 82 and the 83 and the 97 and 98 El Ninos here. Very strong signal here for Southern California with strong El Ninos, but it's not always a guarantee here. And I'm going to show you that here coming up in a next slide. But look at South California during November, December, and January. Not much of a, the signal was a little bit smaller here. It was above average precip, but not nearly as much so as once you got into the February, March, and April timeframe. And here's the North California scattering plot here. Again, it had above average signal for that, but you can see if you look at La Nina winter, some of these fall in above average category as well. And El Ninos can also fall below average. So this is a probabilistic forecast. El Nino is not a guarantee of statewide above average precipitation. And now this is what goes over what happens here during the 2015-16, just monster Godzilla El Nino here. And, a lot of the earlier El Ninos saw 150% of the big ones, at least, saw 150% of the average precipitation fall in California. And then the 2015 and 16 came along and we thought, okay, California is going to get slammed again, right? But that was not what happened. And that's not what climate models had forecast. So what happened here is the storms were there, but they actually pushed further north into the Pacific Northwest here. So it's not a guarantee. You got to stress that when you're dealing with the public and you're talking about passing along general information. Random variability still plays a role, and you kind of have to still wait until you get closer to the individual events. But you can say the dice are loaded towards a wetter than normal season for some of California coming up. It is by no means a guarantee. And finally, taking a look at the global temperatures as they rise. So you can see the red dots are during El Nino. You can clearly see they tend to fall on the upward side of this graph here as we move on into the future, 75 to 2000 to 2022. And you can see the La Ninas tend to be on the southern side of this graph here. So most likely we'll be setting some temperature records here as we go over the next several months here and on in through the early winter and early spring season coming up next year. As you can see, the El Ninos generally warmer across the planet versus the La Ninas here. But anyway, hope you guys liked this. Maybe it clears things up a little bit. Maybe you learned a couple things about the Walker circulation or the Southern Oscillation Index here, and just kind of El Nino in a general sense, and just kind of understand that we're still just dealing with probabilistic forecasts. You still tune in to the forecast coming up. Don't just take the ball and run with it. Hey, it's El Nino and we're going to get slammed here in Southern California with above average precipitation. It's going to be super stormy. Atmospheric rivers and the arc storm are all coming. You got to take that with a grain of salt. You're going to have time to look at the forecast models. You're going to get heads up with any big events that do come in. Keep watching the channel. Keep getting the updates here. And I'll do my regular briefings tomorrow, and I will talk to you guys then.